Hello everyone, my name's Brian, and I'd like to welcome you to my course called Mathematical Proofs on my new channel, Let's Prove It. This course is meant to introduce students to the more abstract and theoretical mathematics. I'm going to treat this as a self-study course, so I've made a syllabus with about 10 sections, and I'm going to try to make a homework set for each section so that students could learn this material on their own if they're interested in learning more about mathematics. So now I'll get into the syllabus. Okay, so here's the syllabus. We'll start here. So the course is called Mathematical Proofs, and the prerequisites are simply just high school mathematics. I'll be using two books. The first is called How to Prove It by Vellman. And the second book is called A Transition to Advanced Mathematics by Smith, Egan, and Andre. So let's get into the syllabus. First, we start off with propositional logic and tautology. So this is kind of recognizing what a mathematical statement is and how we can negate that statement. And then we'll go into conditional and biconditional statements, which are very important kind of backbone of proofs, and we'll introduce two types of proofs, the two-column kind of introductory proofs, and then the more advanced paragraph proofs. And in the third section, we'll begin with quantifiers that allow us to kind of use universal and existential statements in our proofs. After that, we'll go on to set theory, which is a very important part of mathematics, and we'll learn how to prove results with sets. Then we'll go into mathematical induction. There are several versions of mathematical induction, but we'll show that all these versions are equivalent and prove some interesting things using induction. Then we'll go into relations, and especially equivalence relations, which pop up in several more advanced areas of mathematics, such as abstract algebra. After that, we'll take a detour and go into graph theory and combinatorics, which we won't prove any results in, but I just think they're an interesting areas to learn when you're learning mathematics. Then after that, we'll go into mathematical analysis. So we'll begin with rigorously defining what a sequence and a limit are, and then we'll prove several things about sequences and limits. And then last, we'll end with a rigorous treatment of continuity, and we'll prove several results with that. So I hope you all will enjoy this course. Thank you.